So here we are given an equation. We need to prove that 3 times log of a equals x times log of a over b. So let's begin. So we'll consider our given equation, which is a raised to the power of 2x minus 3 times b raised to the power of 2x. This is equals to a raised to the power of 6 minus x times b raised to the power of 5x. What we'll do, we'll divide both sides with b raised to the power of 2x times a raised to the power of 6 minus x. So here also we'll divide with b raised to the power of 2x times a raised to the power of 6 minus x. Then we'll see that where b raised to the power of 2x gets cancelled out and a raised to the power of 6 minus x gets cancelled out. Now we can rewrite our expression as a raised to the power of 2x minus 3 divided by e raised to the power of 6 minus x. And on the right hand side we have b raised to the power of 5x divided by b raised to the power of 2x. Now we are going to use the law of indices. That means if we have a raised to the power of b divided by a raised to the power of c, so that's equivalent to a raised to the power of b minus c. So this will become a raised to the power of 2x minus 3 minus 6 plus x. This will be equals to b raised to the power of 5x minus 2x. Solving, we get e raised to the power of, so 2x plus x will become 3x. Negative 3 minus 6 will become negative 9. So this will be equals to b raised to the power of 3x. Further simplification will give a raised to the power of 3x times a raised to the power of negative 9. So that's equals to b raised to the power of 3x. So here we have broken down the exponent a raised to the power of 3x minus 9 using the law of indices. That means if we have a raised to the power of b plus c, so that can be also broken down as a raised to the power of b times a raised to the power of c. Fine. Now we will get a raised to the power of 3x divided by b raised to the power of 3x multiplied to a raised to the power of negative 9 equals to 1. So what we've done, we've divided both sides with b raised to the power of 3x. In the next step, we are going to multiply each side with a raised to the power of positive 9. So that means we will have a raised to the power of 9 on the right hand side. So this can be now written as a over b whole raised to the power of 3x, and this is equals to a raised to the power of 9. So we have reduce our given exponent, equation into a simplified form, a over b whole raised to the power x whole raised to the power of 3. So that's equals to a raised to the power of 9. What we'll do, we'll take the cube root on both sides. That means taking the cube root on both sides. Let's get rid of the 3 here, and cube root of a raised to the power of 9 will be a cubed. Now let's take the logarithm on both sides. So we have logarithm of a over b raised to the power of x, and that's equals to logarithm of a cubed. So we will use the property. That means if we have log of a raised to the power of b, so that's equivalent to b times log of a. So we'll get x times log of a over b. So that's equals to 3 times log of a. And this is exactly what we are asked to prove. 3 times log of x is equals to x times log of a over b. So this is proved.